Welcome everybody. We got a beautiful question, and this question serves two purposes. One, to show the power of geometry over algebra, and the next one, of course, the concepts that you are going to be learning. Now there is a semicircle that is actually inside a triangle. Now let me draw the triangle. Now this is a right angle triangle, and the hypotenuse side holds the diameter. So this is A, B and C. At C we have a 90 degree, right? So angle C is a 90 degree. Now we are expected to find the shaded region, so this region is required. Okay, so this is the required area, so we need to get this. Now we are given AC is 6 units, BC is 8 units, AB is 10 units, so this is given, and we have to, as I mentioned to you, we are required to get the shaded regions area. Now there is a tangent at D and a tangent at E, right? So there is a tangent at D and a tangent at E. Okay, so what I'm going to do is I'm going to use the all-important theorem. Now if I were to draw, the statement is, if a line is drawn from O to, which is the center of the circle, to the tangent to the circle, the angle made will be 90 degrees. So if you were to draw a line from O to the tangent, the angle made is going to be 90 degrees. Now I'm trying my best to represent the content or to represent the concepts. The figure is little bit not to the expectations, so the most important thing that you have to know is the concept that is being displayed here. Okay, so as I mentioned to you, a line is drawn from O to D, so this is going to be, by theorem, this is going to be making 90 degrees, so that is 90 degree there. Now I can repeat the same thing, a line being drawn from the center O to the tangent, right? Now let me do that. Okay, the figure is fairly fine. So this is going to be making 90 degrees. So you have a 90, you got a 90 here, right? Now I've already mentioned to you, angle at C is 90, so this is 90. So this is 90, this is 90, this is 90. You get 3 90s, and you know that ODCE is a quadrilateral. So let me state that. We see that we observe that ODCE is a quadrilateral. So the sum of the angles inside will have to be 360, but angle D is equal to 90, angle at E is equal to 90, and angle at C is equal to 90. So this means angle D plus angle E plus angle C plus angle at O. But we know that all of these angles should be equal to 360. So you put this angle 90 plus 90 plus 90 plus angle at O should be equal to 360. So this means angle at O should also be equal to 90 degrees, right? Only if this is 90, it will add up to 360. This is the requirement for a quadrilateral. So this is clearly 90 degree, right? So if all the four angles are 90, what are we talking about? The angles are all 90. So if I were to take OE is R, this is also going to be R. So because of the fact that each of these angles are 90 degree, we are talking about a square. So that would mean this is going to be R, this side is going to be R. Now our requirement is to find the radius. So if we can find R, the question is solved. Now the all important point here is we are given AC. AC is equal to 6 units. So this entire thing is given to be as 6 units. If this is 6 units and this is R units, this should be 6 minus R. This entire length is given to be as 8 units. This entire length is 8 units. This is equal to R. So this is going to be 8 minus R. Now this entire length is given to be as 10 units. So if this entire length is 10 units, then we will have to actually extract the values of R from here. Now we cannot do any deductions of the measurement here. We have to just simply take AB to be this entire length to be as 10 units and then work out our way to getting the value of R. Okay, so what I am going to be doing, I am going to be showing you two ways. One is by the way of geometry, the other is the way of algebra. So you can pick the way that you want. Okay, so I mentioned that our requirement, our objective, our requirement is to find R. That is our priority. So if I get R, the question is solved. Good day everybody. We had this question, right? In the previous question I applied the concepts of similar triangles to get the value of R. Now in this case I will be using solely algebra and as a tool and then extract the value of R. Now I'm making it as a separate video because of the intense calculations that have to be done. So clearly I have explained the figure, and now what I'm going to do is I would like to consider triangles ADO. Now clearly there is a 90 degree. So let me just draw the triangles. This end is going to be E. From the figure, AB is given to be as 10 units. So this entire length is 10 units. but we are going to be utilizing OA and OB. And the angle at E, this is 90 degree. This is 8 negative R, and this side is going to be R. And of course I will just consider it as OB. Okay, so our basic requirement is to find the value of R, right? So from triangle ADO, we observe that it is a right angle triangle. So this would mean by Pythagoras we get, so what do you get? AD squared plus OD squared is equal to OA squared, right? So AD squared is 6 negative R raised to the power of 2 plus R squared is equal to OA squared. So also applying the same concept from triangle BEO we get, so what do we get? We get BE squared plus OE squared is equal to OB squared. BE squared 8 negative R squared plus R squared is equal to OB squared. So now we need to solve two systems or two equations. So we got OA squared is equal to 6 negative R whole squared positive R squared, and you got OB squared is equal to 8 negative R whole squared positive R squared. So I will have to perform the simplification. So this is going to be 36 negative 12R plus R squared plus R squared. I can add these two things, so this will give me 2 times R squared. Negative 12R plus 36 is equal to OA squared. This is OB squared is equal to 64 plus R squared negative 16R plus R squared. I add these two things, so you get 2 times R squared negative 16R plus 64 is equal to OB squared. Now I can take 2 out, so this is R squared negative 8R plus 32 is OB squared. So OB is equal to root of 2 times root of R squared negative 8R plus 32. Over here I take 2 out, I get R squared negative 6R plus 18 is equal to OA squared. OA is root of 2 times root of R squared negative 6R plus 18. Now we know that OA plus OB is equal to AB, which is equal to 10 units. This means I can now take OA plus OB is equal to 10, which in turn means root of 2 times root of R squared negative 6R plus 18 plus root of 2 times root of R squared negative 8R plus 32 is equal to 10. So I will show you how to solve this in a minute. So I can take root of 2 out. This would give me root of R squared negative 6R plus 18 plus square root of R squared negative 8R plus 32 is equal to 10. Push this root 2 down. So this is 10 over root of 2, and over here you get R squared negative 6R plus 18 plus root of R squared negative 8R plus 32. I want to square both sides. So this would give me 100 divided by 2. 2 divides 100 50 times. So I will have a 50 on the right hand side. If I were to square this I need to start from here. This is going to give me R squared negative 6R plus 18 plus square of this term R squared negative 8R plus 32 plus 2 times root of r squared negative 6r plus 18 times root of r squared negative 8r plus 32. Okay, 32 added with 18 is 50. This 50 and these two numbers gets neutralized. R squared with r squared is 2 times r squared. Negative 6r negative 8r is negative 14r. Positive 2 times of this entire quantity, root of r squared negative 6r plus 18 times root of r squared negative 8r plus 32 is equal to 0. Take everything to that side. We get 14r negative 2 times r squared is equal to 2 times root of r squared negative 6r plus 18 times root of r squared negative 8r plus 32. Push 2 down. This you can take 2 out. This is 7r negative r squared, and over here you got 2 there, so this and this can be cancelled. Thereby you get root of r squared negative 6r plus 18 times root of r squared negative 8r plus 32. Now what I wish to do is I would like to square both sides. A square here, so squaring both sides we would get r squared negative 6r positive 18 times r squared negative 8r plus 32 is equal to, we have to square 7r negative r squared raised to the power of 2. So this is going to be 7r squared positive r squared raised to the power of 2 negative 2 times 7r times r squared, which is going to be 49r squared plus r to the power of 4 negative 7 times 14r cubed. This is what we have got. So if you expand this, we need to multiply both the sides. So r into r squared, in other words r squared into r squared, that is r to the power of 4 negative 8 times r cubed positive 32r squared multiply 6r, negative 6r with r squared, that's going to be negative 6r cubed positive 48r squared negative 6 2s are 12, 6 3s are 18, 192r followed by 18r squared negative 8s are 64, 6, that's 144r, and then 18 into 32, that will give you 576, which is equal to 49r squared plus r to the power of 4 negative 14r cubed. Now I can't do anything with this, but I can get rid of this. Now this is alive. Now negative 8r cubed added with negative 6r cubed is negative 14r cubed. That can be cancelled. So now after the cancellation we are left with the following terms: 32r squared positive 48r squared negative 192r positive 18r squared positive 144r positive 576 is equal to 0. Now we add this with this, and of course you need to bring this 49r squared that is existing on the right hand side, so that's going to be negative 49r squared. So you add this with this, that would give you 10180r squared, and then you add with 18, so you get 98r squared negative 49r squared, that's one term, and then you add this with this, that is going to give you negative 336r positive 576 is equal to 0. So this is going to give you 49r squared negative 336r plus 576 is equal to 0. Okay, now this is a quadratic, you have to solve it. I'm going to solve it using the quadratic formula. Negative of negative 336 plus or minus root of 336 squared negative 4 times 49 times 576 divided by 2 times of 49. So this is 336 plus or minus root of, you square this will give you 112,896, and then you multiply this with this. So let me show you that. So 4 multiplied with 49, that's going to give you 196. That has to be multiplied with 576. So you're getting 112,896 divided by 2 times, I retain it like that. So this is going to be 0. So you are left with R is equal to 336 divided by 2 times of 49. 2 divides here 1 times, 6 times, 8 times. So you get 168 divided by 49. 7 divides here 2 times, 7 divides here 4 times, 7 divides here 7 times. So R is equal to 24/7. This is the value that we have got by using algebraic technique, and we didn't have to do all of these. I should say this is the value that we got using the geometric technique of similar triangles. And using geometry, it was so quick. But using algebra, we need to solve and evaluate several components. Now, the all-important point that you have to note here is, between the start of the solution, or I would say start of the simplification, and to the point that we reached here, there are many places people can introduce errors. In other words, calculation mistakes. So this technique, though we have got the value for this is not a easy technique, right? But the solutions are one and the same. So having mentioned that, the point that I wish to make here is, geometry simplifies even the most complex application problem. So if you know geometry, that means you have in your arsenal a very powerful tool, and that tool can come in handy in several places where algebra lets us down. Now in this case, I wouldn't say algebra let us down. The only thing is that the technique followed by algebra, or the capacity of algebra to evaluate this, is undoubtedly good. But the probability of arriving at this solution, it is possible, but there is always a probability of people making mistakes. You can try this out and find out by yourself. So everybody, thank you for watching this video. I hope you have learned something, and as Aristotle says, knowledge is power, and as Plato says, application of knowledge is even more powerful. Until we meet again, thank you.